Hi, Assalamualaikum. My name is Nurul Shakina binti Makdau and I am from Group 2. Today we're gonna present the Bayer process, which is for refining bauxite to alumina. So next we move to the next page to what is bauxite and its composition and characteristic. As you can see, the pictures is show how the bauxite looks like. Bauxite is a sedimentary rock and the main source of the metal aluminium. It composed primarily of aluminium minerals, gibbsite, boehmite, and diaspores. It also contains iron oxide like geotite and hematite, and also silica and small amounts of titanium oxide. Bauxite is typically dull and can be reddish brown, white, tan, or combination of these colors. Its texture can range from very hard to soft as mud. The uses of bauxite used as the principal ore for producing aluminium metal through a process called the Bayer process, followed by the Hall-Héroult process. The other use of bauxite is small amount are also used to produce a variety of other materials such as abrasive, chemical, and ceramics.
Hi everyone, my name is Kang Zuli and I would now like to start with the process flow sheet of Bayer process. It begins with the grinding bauxite and then performing the pressure digestion in caustic solution. This reaction forms sodium aluminate solution, leaving the impurity which is then filtered out in clarification step. The liquid is then cooled and seeded to initiate precipitation. And finally, this hydrate is heated in calcination step to produce aluminum, which is our product. And we move to the reaction equation. The bauxite is refined through the reaction. Firstly, digestion. The digestion is to dissolve aluminum oxide in caustic soda to sodium aluminate, NaAlO2. And next, in precipitation, the solution is cooled and seeded, causing the aluminum hydrate Al2O3H2O to crystallize out of the liquid. And finally, calcination. The hydrate is heated over 1,000 degrees to produce our aluminum product, AlO3. Next, I would like to discuss about the unit process. The first step is purely mechanical, which is crushing and grinding. The bauxite is washed and crushed into fine powder. It is used to reduce the particle size and increase the available surface area, ensuring the digestion step is fast and efficient. The second step is digestion, which involves chemicals. The bauxite is mixed with hot concentrated caustic soda solution, and then the mixture is reacted under high pressure and temperature. Under this condition, aluminium-bearing minerals are dissolved to form a sodium aluminate solution, which is called as pregnant liquid, and remaining the solid residue. Furthermore, the next step is clarification. Solid residue are removed. This involves washing and sedimentation step. The chemical additives are used to help the solid to settle quickly. The insoluble residue, which is known as red mark, primarily composed of iron oxide and silicate, is separated from the valuable liquid by filtration. After clarification, the pregnant liquid is ready for precipitation. This is achieved by seeding the liquid. As the liquid is cooled, the aluminum compound naturally crystallizes and grows, resulting in the formation of alumina trihydrate crystal. The crystals are then classified in different size fractions. The larger particles are kept, while the undersized particles are fed back to precipitation state to act as a new seed. After that, we have seed filtration. Here, the fine seeds are separated and pumped to recirculatory tank. This filtration area removes any trace impurity like sodium oxalate and improves process efficiency before they are sent to the final step. The final step is calcination. The filtered aluminum hydroxide crystals are washed dry and then are fed in rotary kiln and calcined. Here they are heated to extremely high temperatures, which are over 1000 degrees Celsius. This drives out the water from hydrate, leaving behind our final product, which is alumina powder, Al2O3.
Assalamualaikum and good evening. My name is Muhammad Muazzam bin Mustafa. I will present environmental challenge and energy usage. And for the second slide is sustainable alternative in refining. First environmental challenge is red mud disposal. Red mud is the largest solid waste output. This highly alkaline slurry poses long-term contamination risk to groundwater. And second, energy use and air emission. High temperature calcination are highly used energy intensive. This led to significant greenhouse gas CO2, NO2 or SO2 emission and thermal pollution. Sustainable alternative in refining. First one is circular solution. The alternative is valorization. This involves processing it for use in other industries such as component in cement, bricks and other construction material, turning a liability into a resource. Valorization means the process of increasing or giving value to something and make it more useful, important, and profitable. Next, reduce energy and water use. Implementing strategy to reduce the high water and energy footprint. This include waste heat recovery from calcination, optimizing fuel sources, and adopting advanced water treatment and recycling process within the plant.
Lastly, for the conclusion, the Bayer's process is the most widely used industrial method for refining bauxite to produce pure alumina. Through the process, bauxite is digested in sodium hydroxide, separating alumina from impurities such as iron oxides and silica. Resulting sodium aluminate solution is then cooled and precipitated to form aluminium hydroxide, which is later calcined to yield pure alumina. So overall, the Bayer's process is efficient, economical, and essential as a preliminary step in aluminium production, providing the high purity alumina needed for the whole hero process of metal extraction.
This is our reference. That's all from us. Thank you for watching.